we are finding dy dx, so we have to do our derivative. So we have y equals x, natural log of y, plus x. When it says use implicit differentiation, that's when we have to look at it. It's not just a plain y equals. We have another y within this problem. So every time we take the derivative of a y, what do we put with it? dy dx. So watch for that. When I tell you use your implicit differentiation, you need to be putting your dy dx. So this dy dx equals. This one, we have to do the product rule. You have an x times the natural log of y. So there are two pieces. So the product rule is derivative of the first, derivative of x is 1, times the second, plus the first, times the derivative of the second. What's the derivative of natural log y? 1 over y, and since it's a y, we also need a dy dx. Plus derivative of x is 1. So simplify this. We have dy dx equals the natural log of y plus x over y dy dx plus 1. Get my dy dx's on the same side. I have two terms. They both have a dy dx, so you can pull it out. That leaves me with 1 minus x over y. Get dy dx by itself, we have to divide. What's wrong with that answer? Right, we don't leave a fraction in a fraction. So what I'm going to do is take top and bottom times a y. So dy dx equals y, natural log of y, plus y over y minus x. So there's my dy dx. So when I say implicit differentiation, make sure every time you do the derivative of a y, you put your dy dx with it. Is that one okay? Number 14, working backwards. Same directions. This time it's y sine 2x equals x cosine 2y. Again, we have two things being multiplied over here, so we have to do the product rule. So derivative of the first, derivative of y is dy dx times the second plus the first, derivative of the second. What is the derivative of sine? Cosine. When you do that, the angle stays the same, but you have to do the chain rule, so times derivative of the inside, derivative of 2x is 2. So remember, in these we have a lot of things that we have to remember. Products, quotients, derivatives of trig functions, chain rule, all of those pieces come into play here. Equals. Same thing over here. We have to do the product rule. We have an x times the cosine 2y. So derivative of the first, derivative of x is 1 times the second plus the first, derivative of cosine 2y. Derivative of cosine is negative sine. 2y stays. Chain rule, derivative of 2y would be 2 dy dx. Okay. So cleaning this up, we have dy dx sine 2x. Am I going to lose you if I bring this term over here? So I'm going to go ahead, this was a negative, so I'm going to add it over, and it would be a 2x sine 2y dy dx. On the other side of the equal sign, I have my cosine 2y, and I'm going to subtract over is 2y cosine 2x. So I just simplified it in multiplying, and I put my dy dx on the same side. So now you factor out your dy dx. And then to get dy dx by itself, we divide. Is this helping? Is it worth my time to work out every problem?
Yeah.
Okay. I figured just talking through some of these would be a good refresher for us. Right. Questions on that one? Let's look at problem 13. I want the equation of the tangent line. But you notice this one has x's and y's all together. So what are we going to have to do with this one? Can I just do a nice clean derivative? No, we're going to have to use our implicit differentiation. Equation of a tangent line. To write the equation of a line, you need a point and a slope. I have a point, I need the slope. How do you find the slope of a tangent line? Derivative. Okay, so we are going to work through this doing the derivative. So derivative of x squared would be 2x plus the derivative of 4xy. Again, there are two variables here, so we have to do the product rule and do the derivative of 4x times y. So derivative of 4x would be 4 times the second plus the first. Derivative of the second. What's the derivative of y? dy dx. Plus, what's the derivative of y squared? 2y dy dx equals, what's the derivative of 13? 0. Okay, we have two options here. On the other problems, we had to solve for our dy dx. And we could most certainly do that here, but I don't really have to yet. If you want, you could go ahead and plug in your point and then solve for dy dx. So it doesn't matter whether you plug in or solve first. I'm going to go ahead and just plug in my x and y. So my x is 2, y is 1. Y dx equals -8 divided by 10. Dy dx is -4/5. Dy dx represents what? Slope. So this is your slope. Now we have a point and a slope, so we can write the equation of a line. So plug into y equals mx plus b, your y is 1, m is -4/5, x is 2, plus b. Add your 8/5 over. So we get y equals -4/5 x plus 13/5. So anytime I ask for equation of a tangent line, you have to do your derivative. Any questions on that one? Number 12. I want to know when the tangent line to this is horizontal. What do you know about a horizontal line? The slope is 0. How do you find the slope of a line? Or slope of the tangent line? Derivative. So we have to start with the derivative. So derivative of y is dy dx. Okay, here the 2 comes down, inside stays the same. We're doing the chain rule. Subtract 1 from the power, so it's just the first, times derivative of the inside. The derivative of the natural log is 1 over the argument. So it's 1 over x plus 4. We said it's horizontal, so that means the slope is 0. So dy dx is 0. Then you could multiply over the denominator. We're just solving for x here. You multiply that over. 0 times anything is still 0. Divide by 2. 0 divided by 2 is 0. Couple ways to solve it from here. One option would be to change this to exponential form. A natural log is just a log base e. So if we change it to exponential, that means e to the 0 power equals x plus 4. You could also just add a base of e to each side, and the e and the ln would cancel each other. If you realize anything about logs, then you might know what this inside has to equal. So a few different options here. What is anything to the 0 power? So subtract your 4, and we get our x to be -3. If I asked for the full order pair, how would you find the y to that? Plug it in. If I put in a -3 there, then you get the natural log of 1, which is 0. I didn't specify that it had to be the ordered pair there, so if you just said x equals 0, I would accept that too. So kind of an ugly one with the ln's in there, but you could certainly expect on the test for me to ask you about some equation having a horizontal tangent line, and just knowing that the derivative is 0 there. Problem 11. A computer company, or a company makes computer chips from square wafers of silicon. It wants to keep the side length very close to 15 millimeters and wants to know how the area changes when the side lengths change. So keep in mind we have a square, which means the sides are the same. So both of these are x. So what's the area of that? X squared. If I ever ask how something is changing, I'm asking for the derivative, and I even kind of told you there. I said find a prime of 15. So a prime, what's the derivative of x squared? 2x. I want a prime of 15, so if you plug in a 15, you get 30. So explain its meaning means when the sides are 15 millimeters, the area, it's a positive, so it is increasing (30 square millimeters). Okay, so what I'm trying to get you to recognize on this one is that a derivative is a rate of change. And we know that if we increase the side length, it will increase the area. So what this question is really asking is, if we're starting at 15 and I increase my side length, how much would I expect my area to change? And that's what it's telling us. Number 10. I can promise you I will have a question like this on your test. We've done several of them in class. We've had them on the quiz. So this one tells us the height after t seconds is given by this equation. So part A wants velocity. How are height and velocity related? Right. Velocity is just the derivative of height. So our velocity is just h prime, which would be 15 minus 3.72 t. So that's our velocity equation. I want the velocity after 2 seconds. So that means your t is 2, so if you plug that in, then you should get 7.56 meters per second for your velocity. Part B wants the maximum height. So first we have to talk about, when do you have a maximum? When the velocity is 0. If you think about it, your maximum is going to happen when it goes up and then switches to come back down. So your velocity is 0. We have our velocity equation, so I'm going to set the velocity equal to 0. Divide, and we get 4.03 seconds. That's the when, but I wanted the height. So what do you have to do with that time? Plug it into your height equation. So you're putting that into the original. Can I just write down the answer versus showing all my work? You guys know what I'm doing there? These questions, the math itself is not hard, but you have to know the relationship between all of these things. If I talk about height, you have to make sure you're plugging into the correct equation. If I talk about velocity, you have to be using the derivative. So you have to pay close attention as you're working these. Okay. Part C. Once the velocity, so we're talking about the derivative, when the height is 25 meters on the way up and on the way down. So what I know is my height is 24. And I'm looking for my velocity. The velocity equation involves time. So I have to find my time first. So what I'm going to do is use the height equation, plug in the 24 for the height. Oh, yes it is, thanks. Set this equal to 0, so I'm going to add over my 1.86, subtract my 15. Okay, I'm trying to find my time. Now, on the test, given that you won't have a calculator, I will have to give you something nice here. So something that you could factor doing box method. Box method is not going to work, so your options are quadratic formula or using a graphing calculator and finding the intersection of the two. Are you okay if I just write down what the 2 times are? Could you work out the quadratic formula if we had to? Opposite of b plus or minus square root b squared minus 4ac all over 2a. So you should get 5.71 and 2.35. Which one would be on the way up and which one would be on the way down? It's going to go up first, right? Because we were starting throwing a rock up. So this would be on the way up. It happens first, and this is on my way down. So now you're going to plug those into your velocity. So on the way up, you're going to plug in your 2.35 for your time, and you get a 6.258. On the way down, you plug in your 5.71. Again, we're finding velocity, so you're putting these in your velocity equation. And why is this one negative? Right. Going up, you should have positive velocity. Going down, you should have a negative velocity. Okay, you really just have to pay attention. Think about, I want a velocity, so I have to plug in the velocity equation. The only thing I can put in is my time, so I had to find my time. Just think about what the question's asking and how to get that information. Part D, when the rock hits the ground. If it hits the ground, what's true? Height is 0. So your original is 0. You could do quadratic formula or something, but we really don't need to. I could just pull out a t. So you get t equals 0, which is because you started on the ground. And the other one, you get t to equal 8.06. So it hits the ground after 8.06 seconds. E, how do you find acceleration? Second. So you need your h double prime. Our velocity, our first derivative was 15 minus 3.72 t. So if you do the second derivative, you just get 0 minus 3.72, so negative 3.72 meters per second squared. So height, first derivative is velocity, second derivative acceleration. Any questions there? Problem 9 talks about your cost. What is marginal cost? Just your derivative. So part A, marginal cost, just means find your derivative. So the derivative of 920 is 0, so we get 2 minus 0.04x squared plus 0.00021x squared. Or this is x to the first, isn't it? B, C prime of 100. So you plugged a 100 into that equation and you get 0.1. I can promise you, I will ask you what something like this means because I want you to understand. A derivative is talking about a change. It does not mean that when you produce 100 items, the cost is 10 cents. What does that tell us about the cost? Yes. So when 100 items are produced, costs are increasing because it's positive by 10 cents per item. That means in order to produce 101 items, I would expect it to cost me an additional 10 cents from whatever it costs right now. Part C wants you to compare that with the true cost of producing 101 items. So this tells me how much my cost went up. So I need to find out how much it really went up between 100 and 101. So if you plug 100 into your original equation, you get 990. So it costs $990 to make 100 items. If you plug 101 into the original equation, you get 990.10107. So the true amount it increased was how much? The true increase was and that's very close to our estimate. We estimated 10 cents and it's really 10.1 cents. So we were very close. They're probably never going to be exactly the same, but we would expect it to be reasonably close. Our derivative is like the estimate, and then we can look at the actual. Questions there? Number 8. The differential. What is a differential? This in the last section. I'm going to ask for a differential, what I'm going to ask you to find. The dy. Okay, you can do this like normal. I apparently really liked natural logs when I was writing this study guide. There are a lot of them on here. It might help you when you get ready to do this derivative. Remember your square root is like a 1/2 power. So your differential, there are different ways of doing it, but maybe the easiest, we know our y when we do the derivative, that's dy dx. That's how we've always done it. Derivative of a natural log is 1 over the argument. Then we have to do the chain rule, so times the derivative of the inside. So derivative of x is 1 plus 1/2 comes down, inside stays the same. Subtract 1 from the power, times derivative of the inside, derivative of x squared minus 1 is 2x. If you want to clean that up, not a whole lot you could do. You could write it as one big fraction if you preferred. We could cancel 1/2 times 2 would drop each other out. So at the very least you need to do that. Then we're trying to solve for dy. I dropped my x, didn't I? Okay. I'm trying to solve for dy, so what would I need to do? Multiply our dx over. So I'm going to be lazy about it. I don't want to rewrite all this. So if I multiply over my dy, or my dx, then there's my differential. Remember, the differential is like your change in a particular variable. So this is our change in y. Is that one okay? Number 7. We're trying to estimate 83 to the 3/4. Keep in mind that 3/4 is like saying the 4th root of that cubed. So we need our function. Our f of x would just be x to the 3/4 power. And we need an A value, which is something close to 83 that would have a nice answer. So what's something we can do the fourth root of that's close to 83? 81. Okay, so we're doing our linear approximation, so we need our derivative for our slope. So if I do my derivative, you get 3/4 x to the negative 1/4. Now you need to find your derivative when your x is 81. It's like saying 3/4 times 1 over the fourth root of 81. Fourth root of 81 is 3, so 3/4 times 1/3 is just 1/4. We need a point and a slope, so that's our slope. Our point, when our a was 81, fourth root of 81 is 3, 3 to the third is 27. So now plug into y equals mx plus b. And then if you subtract that over, intercept is 27/4. So your equation is y equals 1/4 x plus 27/4. Now, what do I do with that? We are trying to approximate at 83, so if you plug in an 83, and we get our 27.5 for our approximation for 83 to the 3/4. You can always check, if you actually type in 83 to the 3/4, it's 27.498, so it's a pretty good approximation. Questions on that? Number 6, another linear approximation. Our function is the square root of 7 minus x, or you can think of it as 7 minus x to the 1/2. And did I have you do a equals negative 2? Mm-hmm. Okay. I had it changed on my study guide. I didn't know if I changed on yours. Okay, and we are trying to approximate the square root of 7.1. So I gave you an a value. If you plug in a negative 2 to this, then you get 7 minus negative 2, so 7 plus 2 is 9. Square root of 9 is 3, so that's our point. We need a point and a slope, so to get the slope you do your derivative. So 1/2 comes down, inside stays the same. Subtract 1 from the power times derivative of the inside. You need to find f prime of your a, so we're going to plug in our negative 2. So that's like a negative 1/2 times 1 over the square root of 9. So negative 1/2 times 1/3 is negative 1/6. So that's my slope. So plug into y equals mx plus b. Subtract that over. So your equation is y equals negative 1/6 x plus 8/3. Now we have to be careful. We have to know what we're going to plug in for our x. I want to approximate the square root of 7.1. Okay, and keep in mind our equation is the square root of 7 minus x. So that means 7.1 has to equal the 7 minus x. So if you add your x over and subtract, your x is negative 0.1. So if we plug in our negative 0.1, we get 2.683 for the approximation. I've got 10 minutes left. It's going to be close. Let's see if we can get through. Are we okay still working backwards? Number 5. Our circumference of a sphere is 90, and the possible error, so that's DC, is 0.5. I want to estimate the maximum error in the volume, so I am looking for dV. Okay, volume of a sphere is 4/3 pi r cubed. So I have to have a radius to plug into this. We don't, so how am I going to get it? We have circumference. Circumference is 2 pi r. So if you do this derivative, since we're just looking for error, every time I do the derivative of a variable, you can put dc or dr. You could write it like this and multiply over the dr at the end. It doesn't matter. The 2 pi is just a coefficient. Derivative of r is 1, so that's 2 pi. So your dc is 2 pi dr. I know my dc. So we can solve for our dr here. So 0.5, we divide by 2 pi. That tells me the dr is 1/4 pi. So that's one piece I'm going to need. I also need my actual radius. So we know the circumference is 90, so 90 equals 2 pi r. So the radius is 45/pi. Now we can come over to our volume. So dV, dr, if you prefer to write it that way, equals 3 comes down, so that's 4 pi r squared. Or that means dV is 4 pi r squared dr. So plug in our stuff. Couple ways you could write it. You could say 8,100 over pi squared. Or if you put everything in the calculator. Oh wait, hold on. I didn't divide by 4. That's not right. It'd be 2,025 over pi squared. Or that's 205.175. This was error in volume. Volume is cubic centimeters. So a lot of errors on the differentials. Questions there? The other 4 questions are all related rate questions. So let's look at problem 4. It's probably the most challenging of all of them. You have a balloon rising at a constant speed of 5 feet per second. So the balloon starts down here, it's going up. I'm going to call that h, my height. A boy is cycling along a straight road at a speed of 15 feet per second. When he passes under the balloon, it is 45 feet above him. How fast is the distance between them increasing 3 seconds later? So this boy is traveling along, we call that x. Distance between them is y. Okay, we know the speed that the balloon is rising. So that would be my dH dt. Anytime you're talking about a rate, that's 5. The boy is riding at a speed of 15, so that's my dx dt. At the instant he passes under the balloon, it's 45 feet above him. Okay, but let's hang on to that. Let's think about it in a second. I want to know how fast the distance is increasing 3 seconds later. So it was 45, but it continues to rise 5 feet every second. So 3 seconds later, it has gone up 15 feet, so it's now at a height of 60. The boy travels 15 feet every second, so in 3 seconds, he has traveled 45 feet. We could find our y at that instant. X squared plus y squared equals your 60 squared. And if you work that out, you get your y to equal 75. So our equation, x squared, hold on, I wrote that wrong, didn't I? It's the right answer, but I just wrote my y is our hypotenuse, so it's 45 squared plus 60 squared equals y squared. Okay, so when you do this derivative, none of these sides are constant, they're all changing. So none of the derivatives are 0, so it's 2x dx dt plus 2h dh dt equals 2y dy dt. Plug in all of your stuff. You're solving for dy dt. I'm not going to show all the work for that. You should get 13. Y is a height, so it's measured in feet. T is time, so it's measured in seconds. It's a positive because the distance is increasing. The balloon's going up, the boy is driving away, so they're getting further apart. Question number 3. I am going to just tell you the correct answers for everything on this page and then see what you want to work out, because I don't think I'm going to have time to do more than one. Question number 3, the correct answer is negative 4.6 centimeters per minute. Question number 2, your z is 5 meters. Question number 1, dr dt is negative 1 over 39 pi centimeters per minute, or that is negative 0.00816. Are there any of those that you want me to look at? Make sure on question number 2, especially, you're watching that ladder problem that got a lot of you in our last quiz. The length of the ladder isn't changing, so when you do its derivative, you get 0. So anything that's constant has a derivative of 0.